Vamos iniciar. Okay, so good afternoon here in Brazil, and also to Fabiano Chaves in the United States. Very pleased to have Mr. Chaves with us today, Dr. Chaves today, participating in this series of webinars that is in celebration of the 20th anniversary of the Wireless Telecommunications Research Group in Brazil. Fabiano, by the way, is alumni of GTEL and UFC. So he is part of this history. We are very pleased to have him today in this special webinar. I'm thanking in advance Fabiano for his availability today. And also with us today in this afternoon, this webinar is Professor Rafael Lima, also member of GTEL, professor at UFC. We will be joining us in discussing, debating the topic that Fabiano is bringing today to us, which is info roads to our future, spectrum allocation for 5G and beyond. Nothing more important and of utmost impact on all wireless communication engineering is a spectrum allocation. So thank you very much, Fabiano, for being with us today. It's very special and symbolic that we are joining us today. And the floor is yours. Please take your time.
Okay, thank you very much, Rodrigo, for this introduction. And it's really a big pleasure for me to be here with you and with some old friends and colleagues to celebrate this special date for GTEL, and also for all of us, because it's really part of our story. So let's start with, I'd like to start first of all with just some overview of this connection between my career and GTEL, because it's really interesting. It's really a good time to recognize the importance of this start, and then before going to the topics that we have to talk about today, I would just like to have just one slide to show this connection. And after this, we will have, I just split this talk in two parts. It's always about 5G and beyond spectrum, but we can have this split as the international level, and then something about what we have in the US. And after this, we can have the discussion with some questions and some additional things. Right, so it was interesting to put this slide to start, just to see, first of all, it was interesting for me to put this because we actually don't have so much time to talk about our career. But at this point, when I was thinking about how to present or how to represent GTEL in my career, I just have this idea of putting here the timeline, and then we can see GTEL highlighted here in green when I was doing my master's studies in the Federal University of Ceará, and it was like something like 4 years of very good and fruitful exchange of knowledge, and in my case, learning from my colleagues and my professors at that time. And I also put here some of the topics that we used to work on at that time, like 3G enhancements, so all kinds of RRM for 3G yet at that time, and of course some topics that were more related with my master's studies, and they were also present in my PhD studies later, like transmit power control, channel equalization, and then also with very good influence from my advisors at those times. I really went through some mathematical tools that were so important for me to understand and to be more open to different tools that you can use and reuse in telecommunications, like game theory, automatic control. So all of these things at that time, like between 2003 and 2010, during my studies, they were really, really important for making the basis that I would need for the rest of my career. And then after this, so after my PhD studies, I really started in the industry, going to Manaus to NOKIA Institute of Technology, where I spent something like almost 5 years, already with projects directly with Nokia in Finland and in US. And then at this point, I think we can start to see the connection of my work and the talk that we have today, so about spectrum. Because at that time, I started already with TV of white spaces, not exactly on the side of research, but already on the side of regulation. So we started with some works on the regulation for Europe, so in CEPT, which is the European Forum for Regulation. And I would say that was my start on this path of spectrum engineering, spectrum management. But at that time also I had, let's say, two paths in the career. So that one was these more regulatory related activities, but also still research on, at that time in INDT, in Nokia Institute of Technology, on Wi-Fi enhancements and also LTE Wi-Fi coexistence. So we had a lot of, I would say, pioneering work, especially on LTE Wi-Fi coexistence. And well, with some changes, I decided to really join Nokia directly, and that happened something mid 2015, when I went from Manaus to Poland, to Wrocław, one of the fourth biggest city in Poland, which is a IT pole in Eastern Europe. And it was a very interesting, very nice experience of 2 years. So I spent 2 years in Poland, and I'm now completing 3 years here in Murray in New Jersey, working with basically with 5G and now 5G and beyond in spectrum and research. But I would say that mostly, at least the last time, has been more dedicated to spectrum aspects. I'm not leaving research, but this balance is a bit more for spectrum now. And in this work, so I have been more active on the US national forums related with spectrum, and all the spectrum discussions and regulation discussions, which are quite connected, and also international forums, so like ITU, as we are going to talk a bit more. So it was, I think it was good to make this introduction, because there is a relation between GTEL in my past, in my background, and also where exactly this topic has started my career. So so let's start with the international level when we talk about 5G and beyond spectrum. So first thing is we have to understand how ITU work on this matter. And we have ITUR as the radio communication sector in ITU, which is responsible for the management of global management of spectrum, which includes allocation of spectrum for so different and diverse spaces, as I just put here some examples, and also the regulatory requirements that you have to operate in order to not have interference between the different services that are using the same spectrum or adjacent spectrum. So here, this list is really long, so I just put some examples that give already a flavor of how diverse is the set of services that we may have in a given spectrum band, and how not so straightforward is to have them sharing this band. So you may have fixed services, mobile services. Inside mobile services, we have IMT as an example. IMT is basically, we are going to talk a lot about IMT. So IMT has to be understood as the 3GPP like, or 3GPP technology. And then you have broadcasting, TV, radio, all types of radio navigation. So space research, so satellites, a lot of different types of satellites with different characteristics. So it's really a very big world that you have to navigate and try to find the best balance between the efficiency in the use of spectrum and protection of existing services. Maybe it's a good information also, this division in ITU about the regions that you have. So they have 3 regions. We, Brazil and the US, are in the Americas, also in the region 2. And region 1 is Europe and Africa, roughly. And region 3, Asia Pacific. So this kind of summary of these divisions that we have in ITU. And of course, these regions can have their own agreements and regulation, or at least understandings, and then they can come to the really international level with these agreements to discuss. So probably most of you have heard about WRC, so World Communications Conference. This is where we have the decisions to change some spectrum use, some regulatory rules and conditions for use of spectrum. And this very big event that takes place like every 3 to 4 years, it depends. And in these very big meetings, you have the member states of ITU making decisions. So member states here is to be understood as the national administrations like Anatel in Brazil and FCC here in US. And the sector members can participate, can of course give some advice, technical advices, and sector members are basically the industry and other organizations, like you can have universities and so all other organizations which are not the national administrations can be called sector members. And this is our case. So the industry is participating in ITU in all these process as sector members. So we are allowed, actually invited to have inputs, technical advices, and so on. But the decisions on WRC are made by the member states. And of course, the interest, the objective is to maximize the global harmonization of the spectrum. And this is a very, let's say, noble objective, but it's not so easy because you have different interests from different industries, from different nations, and maximize the global harmonization is actually a quite broad sentence or statement. But anyway, this is the objective, and of course, for this you have to decide how operations are going to happen in terms of regulatory conditions, which services are going to operate in which frequency bands, and so on. So there's a lot of discussion on this matter. And of course, we always have some geopolitical power play, because that's we are dealing also with the plans, the interests, the preferences of different nations, and of course they want to drive their own plans in terms of spectrum usage. And we always have some discussions and some clear conflicts between some nations that we anyway as industry have to deal with. So this is a general view of the WRC. And then coming back to our point here, WRC 19. So WRC 19 just happened, and if we had to have a single statement about WRC 19 from the 5G point of view, we can say that this is it was a real enabler for 5G and beyond, especially on millimeter waves. So we'll see why. So I've just present a perspective from the mobile industry. If somebody from other industries like satellite industry were to give a talk like this one, they could have a quite different view on WRC 19. So that's just a disclaimer. So in WRC 19, this is just to illustrate how big it is. So we have some numbers here. So this picture shows the plenary meetings where almost 3,500 participants were sharing the meeting and running the discussions. It's, as I said, it's a big meeting. So it is basically 4 weeks of meeting. I'm pretty sure that it's not many people that spend the whole time there. So you have some replacement of people from, for example, from industry. We have people who are spending 2 weeks, then other people spend the other 2 weeks, and so on. So it's a really busy meeting and long. And this is, of course, not something that just happens every 3 to 4 years, but between these meetings, we have a lot of work to do. So this is kind of the end of a cycle. So we somehow call this a cycle in ITU. And this is just the end of a cycle where decisions are going to be made about all discussions that were developed during the whole cycle. Specifically for, let me just, okay. Specifically for this WRC, so for WRC 19, we had really clear priority in 2 agenda items. I mean, from mobile industry point of view. The first one it was this agenda item 1.13, which is related with the identification of frequency bands for the future development of IMT. So that means new spectrum for IMT or new spectrum for 5G. And the other important agenda item was exactly the agenda for the next WRC. So which bands would be under study for the next cycle, which is just starting, right? So the cycle starts just after the WRC 19. So we are now in a new cycle currently. But for WRC 19, we had this this agenda item with all these bands that are listed here, as you can see, this resolution 238 came from WRC 15, which was the previous one, where these bands were decided to be studied during the next cycle, which was finishing in 19. So in 15, it was decided that all these bands here listed would be the ones to be studied for potential allocation or identification for IMT. And as you can see, all bands are in millimeter waves. So that was at that time, just a parenthesis on this. So at that time at 15, this was seen as something not so good from mobile industry point of view, in the sense that the industry wanted to have also mid bands studied for identification for IMT, but that was not the decision of the conference. So the conference decided to go to millimeter waves, and in the end, okay, this is what we had to get to IMT as new spectrum. And as you can see, you have a quite wide and different set of bands. So you had, all of them are millimeter wave, but they have very different, in some cases, they have different incumbents, different conditions, different. So if you are going to do studies for potential allocation or identification for IMT, you could expect at the beginning quite different studies to be done in some of these bands. And this is what happened. Before going into a bit more of detail of these studies, it's just good to look at what happens between two WRCs. So that's why I took the timeline from ITUR Working Party 5D, which is the forum within ITUR responsible for the studies of IMT systems. So here you see that this forum or this group, this working party, they usually have 3 meetings per year, and they take care of all these aspects related with IMT systems. And when it comes to studies that are going to be performed involving IMT systems and other systems, so it's Working Party 5G, which is going to provide the modeling of IMT systems. So all kind of aspects that are important to any consideration about interference that is generated from IMT systems to other systems, any other systems. So this is something that comes from this group. And also the studies related to the spectrum needs, which are also important, because as you saw in the previous slide, we had a lot of potential bands in millimeter waves. But before making any decision about which bands you are going to allocate to IMT, basically the first step is to understand what's the need. So how much spectrum is needed for IMT systems at this point of time. And then this is also one activity which is developed in Working Party 5D. And that was the case for the previous cycle. So we had a lot of studies and discussions about the spectrum needs that we'd have for these bands in millimeter waves. And then the other aspect is, as I said, modeling and the sharing and compatibility studies. So you have to model the system, but you also have to work on the conditions, the scenarios that are going to be considered for the analysis of interference that may happen between the IMT systems and the other systems that are incumbent on those bands. So this is basically an overview of how these things happen in ITU. We can come back later if you have additional questions. I'm not going to go into too much details here. But it's interesting to see what were the expectations of the mobile industry before WRC 19 with respect to all these bands in millimeter waves. And here you see kind of summary of these expectations or preferences. So first of all, for these bands in millimeter waves, it was really clear that the 26 gigahertz band, this one coming from 24.25 to 27.5 gigahertz, that was the kind of primary band for IMT in millimeter wave. So most of discussions, or at least the most difficult discussions during this cycle, the last cycle, were around this 26 gigahertz, especially because adjacent to this band, we have one satellite service, which is called EESS. So it's Earth Exploration Satellite Service. And this is a passive service. So we are going to talk a bit more about this, but this is a service which is really hard to protect because it's really sensitive. And for this reason, we had a lot of discussions about this. And but in the end, we will see the outcomes, and I'll take a bit more on details about this. But first of all, 26 gigahertz was the highest priority for mobile industry. And then we had the other bands like 40 gigahertz, which was also of interest. And 50 gigahertz was in a lower, let's say, level of interest. And basically 6 gigahertz was not so much of interest, but anyway, it was also part of the bands that the mobile industry would like to have it. So this is a kind of big picture of the expectations that we had before WRC 19, and just coming into a bit more of detail about this 26 gigahertz and the most, for sure, the most heated discussions that we had during the cycle. So this Earth exploration satellite, as I said, it is really sensitive, and it is a satellite service which is related with the forecast of weather, so weather forecast, and so it's also sensitive from the point of view of the importance of this service. So nobody wants to cause interference for such an important service. But of course, as I said, when you go to this international level, you have different perspectives. So the satellite industry had really a defensive perspective, in the sense that they wanted really they wanted that the 5G base stations and user equipment would be under a very difficult regulatory limit in terms of unwanted emissions. So as you can see here in this picture, as I said, the ESS band is adjacent to the potential 5G, at that time potential 5G band. So we had something like 250 megahertz guard band, but then still with this guard band, the baseline, let's say, unwanted emissions from 3GPP, for example, they were not able to avoid interference to ESS. So what I call baseline from 3GPP is what they would do in terms of attenuation in the out of band emissions if they don't have any additional, let's say, requirement to meet, right? So they have the baseline, But then we started the discussions and the analysis with this baseline from 3GPP to understand how far we would be from protecting the ESS service. And it was really far. So that was one difficulty. Um, and all those modeling that I talked about had to be really extensively discussed, like all antenna conditions and the deployment characteristics of 5G in this frequency band, beamforming, 3D antenna patterns to take into consideration all emissions that you may have towards the sky. So everything. Um, in one additional difficulty, especially for those who are more used to make analysis and even simulations in 3GPP like scenarios, is that here we are not talking about a terrestrial to terrestrial interference, which we are so used to do in 3GPP scenarios, like one network to another network or one base station to another base station and so on. It's not about this, because the victim is in the sky, and the satellite has a footprint which can vary a lot. Like it can be that at a given point in time you have a footprint covering one big city like Paris, but for other situations the satellite footprint can be even bigger, like covering a whole region in Brazil or even more. So the first or one of the difficulties is how to simulate this, how to simulate so many base stations, how to consider the way these base stations or these networks will be deployed in so large area, because we are used to simulate a number of base stations to make our to do our studies on performance and so on, like 19 base stations, 51, 56 base stations, but that's not the case here. So here we have to look at a very big, very large area, and to consider the number of base stations that are going to be in this footprint, and all these aspects that I mentioned about antenna um, pattern, 3D antenna pattern, and the beam steering, how it is going to be done. How do you consider the dynamics of the beam steering? Because it's no longer as in the past, as you had a fixed antenna, like a sectoral antenna that is fixed, and you can do your studies without moving that antenna. Here you have so much more dynamics, and all of this had to be considering the analysis and in these studies. And this is what we did. When I say we, I mean the mobile industry and also satellite industry, and some administrations, national administrations also came with studies on this specific scenario and case, because it was, as I said, a crucial one. In the end, we had so many even agreeing in the baseline, in all the modeling, all the parameters, input parameters that we had for both systems. We ended up with a so large range of values that were to be defined in terms of unwanted emissions for base stations and UEs, that you can see here in this table. The different values that came to WRC 19 from the regional forums like CEPT, which is Europe. Then you had ATU, which is Africa, the Arab nations with ASMG and so on. So CTEL Americas, of course, with US and Brazil and Canada really being the main players to come to this number regionally. But all these these numbers were just on the table in WRC 19 to be discussed. So the outcome of the meeting, of the conference, should be a given number to remain as a regulatory limit for base stations and UEs in terms of unwanted emissions at this specific band. So we had also similar thing in other bands, like around 40 gigahertz. We also had some conditions to protect the ESS passive service. And I will come back to this point here on the outcome. So here you just see the range of values, and this is in dB watt per 200 megahertz. So it's a completely different value if you go with minus 28 dB watt per 200 megahertz or minus 49 dB watt per 200 megahertz. A completely different condition for base stations and UEs or user equipment. Okay, so that was about the bands that we were looking at to have IMT allocation or identification. The other topic that I said, that agenda item with a high priority, was the bands that would be decided to be studied now in this cycle that we are just starting towards WRC 23. So this is an overview of the preferences that we had before WRC 19. When I see we here is the mobile industry in general. This is coming from GSMA, but it's also important to mention that on these matters, the mobile industry, including the manufacturers of equipment and the operators, they are really coordinated, and at least we try to coordinate as much as possible. And this is a view of the interests that we had for the next cycle. So basically, you can see that now, once again, we have high interest on mid bands, so between 3 and 6 gigahertz, and also we had some interest on bands which are between mid bands and the millimeter waves that we had already. So bands between 6 and 24, because we had already in the previous cycle these bands, these millimeter waves, starting at 24 gigahertz. So for the next cycle, so for WRC 23, our interest was then to look back at the mid bands, and then let's see what we get, or what we got as outcome from WRC 19. First of all, in terms of the first agenda item that I mentioned, so about the allocation or identification for IMT of that spectrum, that millimeter wave spectrum that we had studied for the whole cycle. So the highest priority band, as I said, 26 gigahertz, was really identified for IMT in a global fashion. And the conditions, that was the main discussion actually. The outcome conditions were like this. So you remember that we had that range between minus 28 to minus 49 dB watt per 200 megahertz. We ended with minus 33, which was, I would say, a good outcome for the mobile industry, in the sense that it's still hard to meet this limit, but it is doable. And for sure, some more stringent limits, like those close to minus 40, or even below minus 40 dB watt per 200 megahertz, that would be really hard to meet at millimeter waves. So the decision was actually that this minus 33 for base stations is the first step. So it was a two-step regulatory limit. So up to 2027 September, we may have the base stations operating with minus 33 dB watt per 200 megahertz. After this date, we will have a more stringent limit, which is -39 for the base stations. For the user equipment, all these limits are 4 dB relaxed compared with the base stations, and there are some reasons for this, but they are relaxed by 4 dB. And the understanding in the end is that well, it's hard to meet this value or this limit at this point of time, but it's doable. And also from the other side, we will have more stringent limits when 5G is more proliferated in this band as well, which is also important to avoid interference to the satellites when you have this higher aggregate interference due to a higher number of base stations and UEs operating in these bands. So in this sense, it was a good outcome. And of course, we have still some additional limitations for operating at this band, like some antenna pointing limitations. So you cannot have at this band antenna pointing above horizon line to protect to protect satellites. Okay, so that was about the, let's say, the highest priority band, but we had the other bands, some other bands also globally identified for IMT. That's the case of this 40 gigahertz band going from 37 to 43.5 gigahertz, with some additional let's say regulatory conditions to operate in some specific bands. All of these all these conditions for operation, which are not let's say the baselines, they come to the regulations because of some, of course there is always a reason for this. And in this case, it's for these millimeter wave bands, it has been always some satellite service that is there already as incumbent and to be protected. So we had this additional identification for IMT, and then we had this higher band, like from 66 to 71 gigahertz, that was also identified for IMT, right? So as a summary of this, we can say that it was really successful WRC for the mobile industry. If you look at those bands that were identified, they sum up to something like around 15 gigahertz of spectrum in millimeter wave identified globally for IMT. So it has been seen as a real milestone in the sense of enabling 5G and beyond in millimeter waves, because 15 gigahertz worldwide identified, it can really be celebrated by the mobile industry. All right, so we had some additional agenda items that I'm not going to go into so much details because we may have the time is running. So we had some definitions also about HAPS, the use of HAPS in some of these bands, some of these millimeter wave bands. Just some adjustments of regulation. So I'm not going to so much details. We also had some results about Earth stations in motion. So you can see the picture to have a better understanding of what kind of service we are talking about. And also it was decided that these different eSIMs could use these frequencies that are highlighted here. So especially for this frequency 27.5, 29.5. So now data is one point of interest for this new cycle for the mobile industry, but in the other way around. So we usually are looking for new spectrum for IMT, but at this point we may be looking at in the other side, like looking at the defensive side to avoid interference from this new use of this band on, for example, the 28 gigahertz in some which is used by 5G in some countries. So that's something that actually I think I'm going to talk a bit more later. But this is so this is just one more agenda item that had some outcomes from WRC 19, and we had also something about the 5 gigahertz for RLAN usage. I'm also not going into so much details unless you want to come back later. And then that was about the agenda item that we had for discussion about the bands that we had to study and to decide about the allocation at WRC 19. And then the other agenda item that was important, as I mentioned in the beginning, was which bands are going to be the next, right? So which bands are going to be the next bands to be studied for potential use of IMT and decision on WRC 23, which is the next conference. So as I mentioned before, we had so the mobile industry had a real interest on mid bands, and fortunately, from this point of view, from this agenda item, we also can say that the conference was successful because we got as decision for bands to study in the next cycle all these mid bands that are listed here. Some of them are let's say more related with given region, ITU region, like some of them are more region 1, some of region 2, but we have also some global IMT identification for example, for the 7 gigahertz. It's just 100 megahertz, but it's important. So in this sense, in summary, it was also a successful conference in terms of the bands that are going to be studied. So the next bands to be considered for IMT or 5G. It was also decided to look back at UHF, but this is more related to region 1, so Europe, America. So look back at that and see what can be changed in terms of IMT usage of this band as well. Then we had also other bands like the C band 3.6 to 3.8, but also more related to region 1. And then HIBs. So HIBs below 2.7 gigahertz, that's an important one. It's not decided, not so clear yet which bands are going to be addressed for HIBs. So HIBs is basically, maybe it's not so we have a lot of acronyms here, so it may be a bit difficult for some. So HIBs is basically HEPs, or high altitude platform stations, but for IMT based stations. So the use of high altitude platform stations as IMT based stations. It's a there are some differences for the common hubs. And then I think it's finally we have the 4800 to 4990 megahertz to be also considered for IMT in this cycle that we are just starting. So these are the bands that we see that we look at for WRC 23, but then we had also some agenda items to be considered for the next conference, which where IMT is, as I said, is in a different position. So we are not actually looking for additional spectrum here, but it's important because we are more on the defensive side at this time and for these agenda items, which is not so common. So usually we are seen as the the ones who are always looking for new spectrum. But for at least for these agenda items that we are seeing here in this slide, we actually have defensive perspective, in the sense that some services may cause interference to IMT on some of these bands, not all of them, but in some of them. So that's a bit different condition that we are going to face, at least for these agenda items. Okay, so just some words about the CPM, so Conference Preparatory Meeting for the next conference in 23. This is basically where decisions are made before the conference, before 23, and the first CPM after a cycle like this one is for deciding which groups, which working parties within ITUR are going to be responsible for the analysis in these studies on the different agenda items that were decided in the conference. So it's just here, maybe it's not that important for us, but it's just to understand that we have this work divided in ITU so that the relevant working party or working parties can work together on the different agenda items that we have, which for of course take different problems, different conditions, different scenarios, different systems to study in terms of coexistence and sharing of the spectrum. All right. I think the takeaways from WRC 19, maybe I just gave already a good overview. Then let's start to look at a bit more on the national level. I'm going to talk a bit about the US conditions or US situations in terms of spectrum. But before, just a very general very general statements like about spectrum needs. It's always good. It's very general and very true at the same time. So about spectrum needs, the networks, they will anyway require a combination of bands with different characteristics. So for low and mid bands, you, because of propagation and some other aspects, you really need this kind of bands, so low bands, mid bands for coverage. And of course, when you start to go up, like from low to mid bands, you start also to get in the space of capacity, because you start to get more spectrum or wider channel bandwidths that you are able to use, and that's why it's important to have a mix, with the high bands like the millimeter waves being responsible for this amazing boost on the data rates and throughput. But anyway, for a given network operator, you anyway need to have a combination of these bands if you want to have a service which is not very good, for example, in terms of coverage, but not that good in capacity, or the other way around. So you anyway need a mix. And that's important, especially in the US, as we are going to see. Just one slide before going to the US situation. I just put here a kind of definition of the different spectrum access modes that we may have, with the first one, which I called CSP licensed spectrum, being the one that is most common. So the one where we have the a given mobile network operator licensing the spectrum. So you have auctions from the national administrations, and and that spectrum is auctioned, and the big operators are going to, big or medium, or they are going to buy and or to have access to that spectrum. So this is what we are used to have, but we have some other different types of access for the spectrum. And for example, we may have some locally licensed spectrum, which is not technically not so different from the CSP licensed spectrum, but we have some, you may have some differences, like it may be more limited in terms of geographical areas. It can also be limited in terms of time, so it's not like those 10 to 15 years licenses, but just some temporary license, or at least shorter time. So this is a bit different. So this kind of connected, or at least it seems to be very appropriate, let's say, for private networks. Not that private networks need necessarily to have access to spectrum in this way, but that seems to be a good match. But we have also still other different access modes, like dedicated license spectrum for verticals. For example, you may have for ITS, so railway, and ITS is intelligent transport systems. So you may have some dedicated spectrum for verticals, so it's a bit different. It's already different from the previous two ones. And then we have what you can just say that this is shared spectrum, but we can make a split to differentiate the completely unlicensed spectrum, as we have in the Wi-Fi bands like 2.4 gigahertz and 5 gigahertz. This is really unlicensed spectrum in the sense that you don't have changes in the regulatory conditions or in the regulatory rules for accessing that spectrum, but you have to be the systems that are using that spectrum have to be, let's say, fair. But we have this, what we call here, manage shared spectrum, where we have some good examples in US, like the CBRS, which is just starting to be commercial. And this is quite different because in this case, you have incumbents that have to be protected, but you still share that spectrum, that is originally from those incumbents, but you manage to share that spectrum, and this is not in a way similar to what we have in the Wi-Fi bands, because it requires a dynamic change in some operational requirements, like maximum power, even the channels that you are going to use, and so on. So this is a really different way to access spectrum, and it requires also kind of controller which is outside the network, as in the case of CBRS. You can see also, maybe you can see for those who are more used with TV white spaces, that would be also put in this category, like manage shared spectrum, because you have a database which is going to indicate which frequencies a given device can use at that specific location and time. So it's this kind of differentiation that we use to do about shared spectrum. So you have managed shared spectrum in the other one, which is just unlicensed. You have rules, but you are not going to change those rules, and you don't have any entity which is outside the network to somehow control the access of the spectrum. So after this, I think we can go to what we see as a kind of summary of the US situation in terms of spectrum. There's a lot of information here in this slide, so I'm just going through some. It's good to see the timeline here in terms of spectrum, which is going to which is already being auctioned, or which is going to be. So in 2017 we had the 70 megahertz. Then 1920 we had a lot of spectrum, but all in millimeter wave auctioned, and that's from one point of view, it's very good. So in this sense, we understand as industry, or maybe I should talk more as Nokia. We understand that that's good in terms of millimeter wave. So for US, that's the US is in a good position. But we also see that for mid bands, we have a lack of spectrum in US, at least currently, and but at least we have some plans to close this gap in the mid bands. As you can see here, in 2021 and 21 plus, we have the some spectrum coming to the market in the mid bands. So that's I would say that it's the big picture for US is that. So in millimeter wave, it seems that there is a good US it's in a good pace. But for mid bands, it's really something that even the operators, all or at least a good part of the operators in US, really need this kind of mid band spectrum for 5G. So that would be the let's say big picture about the US in terms of spectrum which can be auctioned. But it's also important to recognize that US is quite aggressive in the unlicensed spectrum, as you can see here in the bottom of the slide, in your right side, the unlicensed spectrum that is in place. It's quite a lot, and this 6 gigahertz band, which is just being released. So the rules for operation this band has been released recently. So it's just 1.2 gigahertz of spectrum at this frequency. It's really huge, and I think actually I'll talk a bit more about this band later on. But it's good to understand that from one side we have, let's say, a good condition in US in millimeter wave, but we are really still working on the mid bands. And on the unlicensed side, I think we could say that the US is also quite aggressive, and it's in a good pace in terms of unlocking spectrum for commercial use. Here, just we are going to the end, so I think I talked a lot already. We are going to the end, but it's just to illustrate how things are going on the mid bands for 5G. And when I say 5G spectrum, well, it's always 5G and beyond, because maybe this comes on in the discussion and in some questions. So when we say 5G spectrum, actually this spectrum, there is nothing to understand that this spectrum cannot be used by 6G. Of course, it will depend on the use cases that 6G may have in the future, but in principle, the spectrum is IMT internationally, and nationally. Some studies will have to be done if the usage of the spectrum is very different from 5G to 6G. But this spectrum, which is being unlocked now for 5G, is in principle available for 6G use in the future. So here, just to illustrate that currently this band, this mid band from 3.7 to 3.98 gigahertz is used by FSS, so fixed satellite service. And the plan is that this will be also a two-phase clearance of the band. Starting at 100 megahertz will be cleared for 5G use. And then in 23, we have the rest of the band. So we have the whole band 3.7 to 3.98 gigahertz available for 5G. So 280 megahertz with this guard band of 20 megahertz for protection of FSS in the adjacent band. So basically, this is a relocation of FSS. We look at this picture, it looks like, okay, it's just relocate and a two-phase process, but it's this is a result of a lot of studies and considerations in terms of how to do this for relocate FSS, and also, for example, this guard band, what should be. So all this is, it has been a matter of studies for those definitions that we see here. So given this timeline for 3.7 to 3.98, so we come back to the CBRS and look at how it will look like the mid-band, the 5G mid-band in US. So in the future, we will have this new 5G band that I just talked about from 3.7 to 3.98 gigahertz. We have now CBRS already operating. It has started in January with only GAA, so General Authorized Access. So the licensed use of this band is not yet started of the CBRS, but the auction is planned for July, so in 1 month. So we should expect then that very soon we will have CBRS full operating from 3.55 to 3.7, so 150 megahertz. And then recently we had already some initial report about the possibility of having 100 more megahertz just below CBRS. So this has been performed by NTIA, so government organization, and it looks like we have a good potential for some spectrum sharing option that can also work for this additional 100 megahertz just close to the CBRS band, so that we can have this let's say 5G mid band in US with a better conditions for the operators. Right, this is my last slide, just to talk about this unlicensed 6 gigahertz usage that has been recently defined by FCC. So the rules that were defined for this 6 gigahertz. So this is, as I said, it's a huge amount of spectrum at these frequency bands. So and some different usage of this spectrum is also foreseen by FCC, as we can see in these rules. So you have this standard power, which is quite interesting consideration from FCC, in the sense that we may have higher power than usually we have in these unlicensed bands, but with under the condition of having an AFC, which is an automatic frequency controller, to take care of the incumbents, so to protect the incumbents. And in this case, specifically for these bands, which are these Uni 5 and Uni 7, we have a lot of fixed links. And in the US, it's a very important service, because many of the operators use these fixed links for backhauling, for example, and you have other usages as well for these fixed links. So they have any way to be protected. And FCC understands, of course, a lot of studies were provided to FCC from different parties to discuss the protection of this fixed service, but they understood that these limits and the use of AFC is enough to protect the fixed links. This is for standard power. Then we have low power indoor, so it's only for indoor, and they have power limits similar to what we have in Wi-Fi, other Wi-Fi bands. And they also considered a very low power device class. That's interesting. This should be something usable by use cases like wearables or very short devices with short distance communications. But the limits for this usage is still under consultation, and this is also important topic for the mobile industry in general in the US. Okay, I think that's what I had to talk about, but we can of course have some discussion, questions, and comments from your side.
Yeah, excellent. Thank you, Fabiano. Excellent. Actually, a short tutorial on the spectrum allocation. It's much more than we could expect. It's very good because we that work in research, as you just pointed out in the beginning, of course, spectrum is the essential resource. But we are not really, usually not that close to the minutiae that is involved in spectrum management. And so you gave here a very close and realistic perception of how these things work in practice, these discussions. And at some time you use this terminology of attack and defense. It's I was thinking quite interesting that seems to be really tough discussions and a dispute of space in the spectrum bands. So that's really interesting. Well, I would like to invite Professor Rafael Lima to join us in the discussion. We have some questions from the audience, and maybe Rafael as well has some questions and comments as well. Please, Rafael, do join us.
Hello, everyone. Thank you, Rodrigo, for the invitation. It's a pleasure to this opportunity to celebrate this achievement of GTEL. GTEL Lab is very important in my history. I started in GTEL as an undergraduate student, and then I did my master and PhD, and now I'm a professor with collaboration in GTEL. So thank you for the opportunity. And it's good to see Fabiano again. And congratulations, Fabiano, for the presentation. It's very nice. I could see how hard is the spectrum management. It's in fact a very intricate task with many restrictions. And I also like the beginning of your presentation that you have shown the evolution of your career. And the first point I would like to ask you, it's a non-technical question. In fact, in this week we had many experts in industry, academy, and regulators, and we have here in the audience some students supervised by me and some Rodrigo students, and I would like to that if you could make some could give some directions to these students about how to succeed in the career. We could see that you have a very interesting path until you are now. So if you could share with them and with us, what are the basic ingredients that you can identify to succeed in this career?
That's a very interesting but very difficult question, I'd say. Yeah, I would say that one important point that I see as crucial for, first of all, I think you have to think about if you really want an international career or not, because maybe um, the process is a bit different in the sense that you may also just don't be so let's say don't plan things so much and just go to the maximum that you can do, and if it happens, you can decide if you have a opportunity to have an international career, you are going to decide. I would say that that was my case. I never made so long-term plans, um, in the sense that I always tried to, first of all, during the studies, be, maybe it's something easy to say, but well, be at the same time focused on your research topics, but don't lose the general, the big picture view of what you are doing, in the sense that you can have, it may happen for some, like you may have some topics that you are so passionate, or even that you are so good, and it can just bring you to this passion, because of course you are, if you are good in something, you get some recognition by this, and you want to do more, and so on. That's actually something that is natural. But I would say that it may happen that you focus too much your research or your topics, and then it's a bit hard later to have a big the view of all things. And for the international career, especially on the spectrum side, I would say that you really need to have a wider understanding, not only on your industry, but also on the other industries, because you are going to interact so much with them. So there are a lot of different and possible paths. Even for an international career, you can just go as a researcher, and then if you are very focused on your system, like in our case, if you are really focused on IMT or 3GPP technology or Wi-Fi technology, you are good to go internationally. But that will also pave the path that you are going to take, because if you are really focused just in your technology, you are going to work on this, because you are not going to have these additional information and the skills that are really required when you go at this level of debating with other industries, or going into this maybe a bit more different. Even the regulatory part of this work is also something that requires you additional skills. I'm still more on the part of more on the technical part than on the regulatory part. So a good thing is also that you may have this is a bit split in a group when you are working on these aspects. You have some people who are more expert on the regulatory part, and other people are a bit more technical. So you can also split this. That's not a big issue. But even if you are the technical branch on this work, you have to understand very well all these aspects in terms of other systems technically. And if you are going to spectrum discussions internationally, you also have to understand the political part, because it's a really strong one, especially when you go to IT. You really have to take into consideration that the technical basis is there. You are there to present this, to give these advices and so on. but there are other aspects that have a lot of weight as well. So you should be prepared and not be, let's say, frustrated if something that you are so confident and it's so clear for you that technically it's the best way to do, but it might end up not being the final decision. So to summarize, for those who are starting their career, nothing so original to say, but I would say that follow those topics and those things that you really like, because you need to work a lot. So if you need to work a lot, it's better to work on what you like, right? So choose these carefully, and also take some time to look around and see what other things in other aspects of this work or this topic, how they interconnect with other industries, or even going a bit more, let's say, in a small scale. You can even just start going from 3GPP technology to Wi-Fi, and you start to have it's already a different world. So they seem so close, but it's already a different world, and you can start doing this to have a better view of what happens around what you are so used to work on. And then that's probably the first step, and then you can start to look around and other systems, how these things work together, and so on. So that I would say that in just one or two sentences for your question, it would be at the same time focused and broad, if possible.
Okay, thank you for the detailed answer. So please, my students, take notes. So, okay, Fabiano, I have some technical questions for you also. You talk about the ways that that the spectrum is offered to operators. You mentioned licensed, unlicensed, and shared spectrum. I would like to know if you see in the future that we can have a more common way to offer spectrum. If, for example, shared spectrum is a tendency in the future, or you think that licensed spectrum will still be needed for operators. What is your opinion about this?
Yeah, yeah. We can say something about this, but I would say that for the future, we may have some convergences or differences from what we have now. But I see already a kind of flexibilization of the conventional way of having spectrum usage. I'm calling the conventional way this just operators, big operators, auctions from administrations and so on. So that would be the conventional one. But we have already some flexibility on top of this. Even this locally licensed spectrum, it seems to be a good way to start the flexibility on this, let's say, conventional spectrum. So you may have one operator which has a given band, and this operator can start to just separate a small part of this band for what we call here local license. So this local license can be, who knows, it can be one enterprise, can be one shopping center who just want to use that specific slice of the spectrum of the operator, but with a bit more, let's say, control over it. So it's different to have a kind of dedicated spectrum for that specific geographical area than just having the conventional spectrum, which is offered conventionally by the operators. So this is at least my point of view is that this local licensing is already a kind of start of having more flexible licensing than what we have conventionally. And in addition to this, what we see, for example, in CBRS in the US is also something that is remarkable in this sense, because we will have in the same band auction spectrum and general authorized users. So the spectrum which is just basically unlicensed, but it's the same spectrum. So what you are going to have is those who auction the spectrum have the license for this, so they will have some guarantees that they will have that specific spectrum that was auctioned. But when they are not using that spectrum, or where they are not using that spectrum, so the spectrum will be available for unlicensed use. And we are talking about the same frequency band. So it's already also a good step on towards the flexible use of spectrum. In the future, we don't know. So it might be that this local license, it depends on how these things are going to evolve. If the process and the automation of this spectrum usage shows to be really reliable and efficient, so we can start to see something getting bigger in terms of having the conventional spectrum being a bit more dynamically used.
Yes, thank you for the answer. Another question, Fabiano. I could see that you have worked with LTE and Wi-Fi coexistence in some papers. And we have in release 16 the new radio unlicensed that can work with licensed and unlicensed bands in a carrier aggregation, or can work in a standalone way only in unlicensed bands. My question is, can you see the potential of this new technology, especially the standalone new radio unlicensed in US, and what are the use cases? What is your opinion about this? We already have the LTE multiplier that operating in unlicensed band in a standalone way. So what's your opinion about this? Do you see any potential in US market for this?
Yes, I think it's probably in other places it will be also important, but in US it's very important because, as I showed you, we have a very good amount of spectrum now available in an unlicensed way. So especially with this 6 gigahertz band with 1.2 gigahertz spectrum available, that's really something that is very important in the point of view of use of spectrum. And it's not only for Wi-Fi, so it's unlicensed band that can be used for 3GPP technology as NRU. And so in this sense, the mobile industry is really interested in investing in the use of this spectrum by 3GPP technology for sure. And I would say that even the operators are quite interested on doing this, but they at the beginning we should expect this not as a standalone use, at least at the beginning, because for sure the operators want to make to be aware of the level of let's say usability this spectrum will have, and if it's reliable or not, how reliable it would be, or if it would be much more a kind of carrier aggregation way to use the spectrum, right? So and I understand the operator, so I think they are right in the sense that let's first of all start with A carrier aggregation like usage of this spectrum. You can use NRU, for example, and so on. But for a standalone use, okay, it's possible. It can be a good usage of the spectrum, but I don't think it will be at the beginning. So I would expect this coming later if it proves to be reliable enough.
Yes, in fact, a new radon license in a standalone way, I think maybe some problems to provide quality of service, for example. And I agree with you. Okay, Rodrigo, from my side, these are my questions, and I think we can see we have one question from the audience. Fabiano, you can see the question in the Q&A button.
Let me
So
try.
I try to translate here. The question is a question from André Cavalcante, and he says that WRC has take decisions every 4 years, and in general, regulators in some countries need take some decisions in a most often way about options and something like that. So the question of Andrea is about what's the alignment and relationship between WRC and the national regulators about this issue, about this mismatch in time frame decisions.
Right. Yes.
Let me just add, Fabiano, that
Sure.
in Brazil we will have the auction for 3.5 gigahertz expected later this year. We hope it doesn't delay because of the pandemic. But then the question from André Cavalcante is very much the one that I would like to make myself. Seems that sometimes ITU is like trying to harmonize decisions that have been taken by the national regulators already. Is it? Well, please clarify.
That's true. Yes. Yes. In ITU, the intention is always this one, so harmonize spectrum as much as possible globally. But the national administrations are not tied to some of those ITU decisions, in the sense that for some bands you have nationally a different usage than what you have determined in ITU. What is more critical from the ITU decisions is some aspects related with the international use of the spectrum, in the sense that if you have border with other countries, so that's more critical in the sense of the ITU decisions. And also, as you mentioned, Rodrigo, it's also quite common to have some decisions made by administrations just driven in ITU to have the global harmonization around them. So it's not that everything is decided in ITU and then it comes down to the national administrations, but the other way around, I would say that's much more common. So in this sense, Anatel, FCC, all national administrations have their plans on how to manage the spectrum nationally. They just cannot and wouldn't never do something that would harm services which are really dependent on the international rules, like satellite, radars in aircrafts, and all these kind of things that are which have these rules defined in ITU for international usage. So these are more critical, right? But those these bands, which can be somehow allocated, you can have these, as we had, as I showed you in US, these relocation from fixed satellite service from this band to give space to 5G. So all these kind of things, the national administrations, they have the authority to do this nationally. So it's not depending on, and at the same time, ITU, let's say, allocations, they are quite broad in the sense that in many of these bands, you have allocation for many of these systems. So nationally, you are going to maybe decide which system is going to really use that spectrum, but internationally, you may have, for example, for just an example, you may have one band which in ITU has allocations for fixed, mobile, and some satellite services. But nationally, you can decide if fixed and mobile will be really using that specific band or not. So it's, in this sense, it's quite flexible nationally, except that you cannot make usage of the spectrum that will cause some interference for these more international services like satellites. And
Very good. Excellent.
Okay, thank you, Fabiano.
Yes.
again, thank you, Andre, for the question. Good friend.
Yeah. Yeah, I think we don't have any further questions for the moment. Let me just check on YouTube if we have any particular question, but I don't think so. Rafael, do you have anything else to ask for Fabiano today?
Yeah, if nobody has question, I have one more question, Fabiano.
Please.
Fabiano, you work also with game theory, transmit power control. So there are some projects in US that we could see that propose the use of artificial intelligence to dynamic spectrum access. And what's your opinion about, do you think that the use of artificial intelligence is a correct tool to this application, or you think it's just a hype? We had some discussions about this in some previous webinars during this week. What's your view about this?
Yes, yeah, that's also a good question, because I think most of us would agree that there is a hype on these tools that are very important and powerful for sure. But I'm also on the team which is a bit skeptical about the usage of these tools. Not in the sense that they are not going to help in any place, but I'm just a bit careful about the problems that we are going to attack with these kind of tools, because I think there are a lot of problems or subjects that have been studied for so long time, and you have so good, close to optimum, if not optimum, solutions for this. And for this kind of thing, well, I really don't see the reason for looking at other tools that, okay, they are interesting, they are powerful, but maybe we should, not maybe, but I really believe that we should look first of all at the problem that is going to be attacked, and see if these tools are really appropriate to those problems, in the sense that, for example, I can see some points where you can have some gains by using artificial intelligence, machine learning, but I think they are more related with sensing, maybe. So just thinking loud here, but for some of those problems that we have, I don't see these kind of tool being helpful unless to do the same, let's say, to give the same results that we have already, or very close results that we have already with other tools. There is also one possibility of having some let's say, looking at another possibility of gain by using these tools is if you can decrease complexity of some process, okay, it's also interesting. It's not just about performance. You may have already a good performance, and then applying these tools, you are going to just have some minimal increase. But if there are some topics where these tools can at least decrease let's say if you can decrease complexity, it's already a gain, which is important, right? So my view is that it's really case by case that you have to use these tools as any other ones. So you have so many mathematical and optimization tools. Not all problems are going to be tackled by one of them. So you have really to analyze the problem and the most appropriate tool to attack that problem. And yes, it may be that some of those problems may be a good shot for artificial intelligence, but I'm always I'm always looking more at these at the problem itself and the appropriateness of using these tools to the problem. Because once you have identified that the problem and the tool are matching, so the way is easy, right? So after this, the problem is really understanding. I think the main point is understanding the problem and understanding which tool would be the most appropriate to solve that problem. Once you have this, well, the tools themselves, they are kind of well known. I know that artificial intelligence is still, let's say, developing, not so it's not so well consolidated as other previous tools. But anyway, for attacking the problem, I think first step necessarily is to understand if it's really meaningful to use that tool to that problem.
Like it, Fabiano's position very much very neutral to the actual applicability of these tools. We academics, the academics are in this business of publishing results, and as such, these hypes in certain way helps to publish a lot of papers. Many times in problems that were already solved, but we revisit those problems with a new tool. Many times the gains are really not that much large, but then the investigation itself somehow is interesting. Yeah. But the hype itself, I agree, it doesn't help us to really understand what's the real potential. I just remember, I think it was last week or so, that there was an experiment in physics in the South Pole that detected some neutrinos coming somewhere, and one physicist made a comment that that could be the proof of the existence of a parallel universe. This was just a comment he made informally, and then these journals that are more speculative, proof of the existence of a parallel universe was somehow discovered in the South Pole, and all of a sudden the whole research team had to rebuke this statement, saying that this was just a speculation and so on. So we have to be really careful, and in this sense, the hype doesn't help. We are at GTEL by around 2 years now looking at those AI tools. They do very much the same, sometimes a little bit better than the usual approach for optimal solutions. So I like your comment, because other dimensions of complexity, maybe energy efficiency as well, in some sense, other dimensions may be interesting to look for than that extra bit per second per hertz that we are always chasing in these investigations of only looking at performance, at the capacity performance, and so on. So that's a very appreciated position coming from from you, and I think the students should also pay attention to someone who is really looking at practical problems, how to approach those waves of hot topics that come and go.
Yes, I lived kind of wave as well with game theory. So
Yes, that's true.
so it was. I think it
That's
was
true.
not so big wave. Maybe it might be just my understanding, but I think
It was, yes.
yeah. But it was kind of wave hype on game theory, like it could be applicable to any problem that you have and so on. So, but it was good to be at that time learning this tool, because it was interesting to understand the limitations of the tool and when it's really meaningful to apply it. So that's why I think it's similar to what we have with artificial intelligence and so on. So every tool has limitations and are better applied to some set of problems, not all of them.
Yeah, we're still learning along the technique itself. Okay. Well, I think we have run out of questions for the moment. And Rafael, anything else on your side?
Oh, Rodrigo, nothing from my side. I would like to thank you and congratulate Fabiano for the presentation and wish success in your career. Good to see you.
Thank you very much, Rafael. It's a pleasure to see you.
And thank you, Fabiano. Thank you very much. That was quite a short tutorial on spectrum allocation, very clear. Thank you very much. I'm very pleased to have you today. Very symbolic of this our project, this story, the history of GTEL to our alumni, and you are one of those alumni that give us a lot of proud. So thank you very much. Good to see you. You haven't changed nothing, right? You're the same guy. I think it's been maybe 10 years. I don't see you in person, but you are the same.
Thank you very much.
Yeah, and we don't know when it will be possible now, but well, who knows? You come here to your homeland somehow, someday, and we have some chat and beer together.
Sure. Thank you very much, Rodrigo. It was a real pleasure to be with you this afternoon for all of us. So it's almost the same time for me. It was really good and a pleasure to be celebrating together with you 20 years of GTEL.
Great. Okay, thank you. Okay, thank you all. Thanks everybody who has been with us the whole week. All these seminars are already in YouTube, including this one. So if you have someone that you know that missed it, you can check it later on YouTube. Okay, so bye-bye. See you. Take care.
Thank you.